am Dr. R. Soumya, Assistant Professor, Department of Electronics and Communication Engineering. The subject is EC3351 Control System. Unit 3 is the Frequency Response and System Analysis. Here we are going to see the topic Bode plot. Let us consider one problem. For the following transfer function, draw the Bode plot and obtain gain crossover frequency, phase crossover frequency, gain margin and phase margin. So the problem is g of s equal to 20 by s into 1 plus 3s, 1 plus 4s. Here the first step is we have to substitute s equal to j omega in the transfer function. So g of j omega equal to 20 by, substitute s equal to j omega, so you will get j omega 1 plus 3 into j omega into 1 plus 4 j omega. Next we have to find the corner frequency. So there are two corner frequency we can find from this transfer function. Omega c1 equal to 1 by 4 equal to 0.25, omega c2 equal to 1 by 3 equal to 0.33 radians per second. Next I have to make one table. So first column we have to write the terms. Okay, so what are the terms is present? So here we have 20 by j omega, this is the first term, and 1 by 1 plus 4 j omega, that is the second term. 1 by 1 plus 3 j omega is the third term, and the corner frequency, corresponding corner frequency we have to write. So in the 1 s by 20 by j omega there is no corner frequency. The second term corner frequency omega c1 is already found, 0.25, omega c2 is equal to 0.33. Next slope in dB. So the first term the slope is minus 20. Y means the s is in the denominator, so it is minus, and s only one term is present, so 20. Like that the second term 1 by 1 plus 4 j omega, the j omega term is in the denominator, so it is minus, only one term is present, so 20. The same way third term is minus 20. So next we have to find the change in slope. So minus 20 equal to minus 40, and minus 40 minus 20 equal to 60. Next, so already we found we have a two corner frequency. Next we have to find the another two corner frequency, that is lower corner frequency and upper corner frequency. So we consider the lower corner frequency omega 1 equal to omega L equal to 0.025 radians per second, omega h equal to 3.3 radians per second. Calculation of gain. Now we are going to plot the magnitude plot. The magnitude plot is drawn between the omega and the gain A. Okay, so for omega find the magnitude at omega equal to 0.02, that is equal to 20 log 20 by 0.02 equal to 58.06 dB. Next find the magnitude at omega equal to 0.25. So the formula is A equal to slope from omega 1 to omega c1 into log omega L to omega 1 plus gain of the previous one. So you will get the answer 38.06 dB. Next find the magnitude at the corner frequency omega equal to 0.33. So the formula will be slope from omega c1 to omega c2 into log omega c2 by omega c1 plus gain of A, that is equal to 33. In the same way we have to find the magnitude for the higher corner frequency, that is 3.33. Next, calculation of the phase angle and the different values of the frequency, that is represented as the phase plot. So we have to draw the frequency and the phase. So omega equal to 0 means the 5 angle value will be minus 90, and omega equal to 0.025 means the angle value will be, phi value will be minus 99. In the way we have to find the omega pi value with respect to the omega. So this is the similar graph. We are going to find the gain margin and the phase margin. So the black line indicates first we have to draw the 0 dB, that is x-axis is the omega and the y-axis is the a. 0 dB, first you have to draw one dot line, and next you have to plot the magnitude plot corresponding to the omega value and the a value. So we have to draw the magnitude plot by using the red color, and next one is we have to draw the phase plot. The phase plot is drawn between the phase value and the omega value. So in the magnitude plot, when the 0 line cut the magnitude plot, that frequency is known as, that is the gain crossover frequency. In the same way, when the 180 degree line cut the magnitude phase plot, that point is known as the gain crossover frequency. Next, when the gain crossover frequency is touch the magnitude plot, and the difference between 180 degree minus that that angle is known as the phase margin. In the same way, when the phase crossover frequency touch the magnitude plot and the difference between 0 dB and that plot is known as the gain margin. So calculation of the gain crossover frequency, the frequency at which the dB magnitude is 0, then that is known as the gain crossover frequency. Omega g is equal to 1.1 radians per second. Next one is calculation of the phase crossover frequency, the frequency at which the phase of the system is minus 180 degree. Omega pc equal to 0.3 radians per second. Next, gain margin. The gain margin in dB is given by the magnitude of dB magnitude at phase crossover frequency. Gm equal to minus 20 log g of 0 omega, that is equal to minus 32 dB. Next one is the phase margin, r equal to 180 degree plus phi, that is equal to 180 degree plus minus 240 equal to minus 60. So conclusion, for this system, gain margin and phase margin are negative in value, therefore the system is unstable in nature.